What's going on, everyone? Homework assignment 19. Today's objective, I can identify and classify rational numbers, and I can write rational numbers as fractions. Let's go to vocabulary. Again, make sure you have all vocabulary, all the examples I give, and all of the problems you see done here, all should be copied in your notes. I've been noticing some people are lacking that, so make sure you have that. Rational number, any number that can be written in the form a over b, where a and b are integers, and b is not equal to 0. So when we say a over b, we mean a over b, and we're saying that they're both integers, where b is not 0. Because remember, if b is 0, that can't be divided. That's an undefined term. We cannot have a number divided by 0 because it simply just will not exist, right? We're going to recognize it as undefined. Examples of rational numbers are, let's say, 0.87, negative 23, negative 2.56 repeated, 1 1/2, all great examples of rational numbers. All of these numbers can be written in the form of a over b, where a and b are both integers. An irrational number, really be the opposite of a rational number. It's a number that cannot be expressed as a over b, where a and b are integers, and b does not equal 0. Another thing we could say about irrational numbers, irrational decimals will be non-terminating, non-repeating. Non-terminating mean they'll never end, and non-repeating means that there's no specific pattern that we could track from it. So examples of it could be something like pi, something like 1.27314. Notice how it says ... That's just telling us that it's going to continue in no specific pattern. And we haven't seen it yet, but I'll include it in the list. Another example of an irrational number would be something like the square root of 2. But if you have questions about that, we can talk about that in class. We won't deal with too many square roots this year. So let's get to, I guess before we get to any examples, I do want you to have this just so that we can have a good sense of our place values. So copy this exactly as it's written. This is an example of the number 0.64, or we could say 0.64, just to show our place values. So we know that after from our decimal point to our left, we have the ones place, the tens place, the hundreds place, the thousands place. To the right of our decimal, we have the tenths place, the hundredths, the thousandths, the 10,000ths. Right, so just a good reference. That way, once we talk about place values, you can refer back to this as to what places are different values in. All right, so let's start here. Writing each rational number as a fraction. So again, a bit of a review from last year. So 6 1/6. So remember, when I turn 6 1/6 as a mixed number into an improper fraction, I start by multiplying 6, my denominator, by my whole value. So I multiply those two. And then I add whatever that is to my numerator. So 6 times 6 is 36, plus 1 is 37, and I keep my denominator the same. Negative 23 can be written as a fraction as negative 23 over 1. 4 2/3, same deal as that first example we saw. Multiply my denominator by my whole, add that numerator. 3 times 4 is 12, plus 2 is 14 over 3. And finally, 7 can be rewritten as 7 over 1. Last bit of examples. Writing the following as fractions in simplest form. So if you ever have to write a decimal as a fraction, here's what we do. We identify the place that the smallest digit is in. So in this case, 0.644, if I take a look back at my list, at my place values here, so the 4 is actually right here. It's in the hundredths place. So because in 0.64, the 4 is in the hundredths place, what I'm going to do is I'm going to take 64 and I'm going to divide it by 100. So 64 divided by 100. Okay, so that is a fraction, not in simplest form yet, but we're going to get it in simplest form right now. So common factors. I know a common factor would be if I divide the top and bottom by 4. We'll see how far we can break it. I know I get 16 over 25, and I think that's as simple as we can make it. So 16/25 is the fraction in simplest form. All right, we'll do a similar idea with the other one, with the next one. So 9.675 as a fraction in simplest form. Well, let's see. What place is my smallest digit in? Smallest digit is in the thousandths place. So I'm going to take just the decimal point of this. I'm going to take 675 and divide it by 1,000. All right, and I know I'm going to simplify it. I'm going to divide, I know 25 is a factor. I don't know if it's the smallest factor, but let's find out. So I'm going to use my calculator. 675 divided by 25 is 27. So 27 over 100 divided by 25 is 4. And that cannot be simplified anymore. So I'm going to include the whole value now. So don't forget that we had a whole here. So it's going to be 9 and 27 fourths. But we can turn that 9 and 27 fourths actually into a oh, I divided by, I see what I did. Hey, look at that. Sometimes we make mistakes. So 675, that should have been over 1,000 because that was my thousandths place, not 100. By 25, I knew something was wrong there. 1,000 divided by 25 is 40. Now that has no other values. Okay, so now we have 9 and 27 40ths. Awesome. Let's turn that into an improper fraction. 40 times 9 is 360 plus 27 is 387. So 387 over 40. And we really can't simplify that anymore because 27 40ths wasn't simplified anymore. There's our fraction. Sorry about that mistake. It happens. Last one. Smallest value is in the tenths place. So I'm going to take that value. So I'm going to take 2 divided by 10, which we know I can simplify by dividing the top and bottom by 2, which will give me 1/5. There it is. Check out practice problems. Any questions, jot them down, bring them to class. I'll see some of you tomorrow, some of you asynchronous. Either way, if you got questions, always Jupiter.